Hello everyone, I'm Jason Sikes, aka the Tech Rancher, here with the solution for homework lesson number 17. The course is over Raspberry Pi Pico W by Paul McWhorter. You can check him out on YouTube at Paul McWhorter, or you can check out his website at www.toptechboy.com. Alright, enough talking about Paul, let's go to the homework lesson. Paul wanted us to be able to come up with a circuit that had a push button and red LED. What he wanted was when the push button is pressed, the red LED would come on and remain on until we push the button again and then it'll come off. As you can see here, I have a red LED and a push button just like he required, and I'm running off of pin 15 or GPIO pin 15 coming through a 330 resistor. It's just carrying over to the anode leg of the red LED. Cathode legs coming to the ground. Now over here to the push button. GPIO pin 14 coming to the pin, our push button, and then we have ground tied onto the other leg. Let's go for those who are going through an engineering course or those who already know how to read schematics. This is a schematic for it. For those that don't know how, I'll go over it real quick. This is a representation of our Pico W. These are the GPIO pin locations, and this is the physical pin location. We're coming off of with GPIO pin 15, coming to the red LED, or going actually first to the 330 ohm resistor, then going to the anode leg of the red LED. Cathode leg goes to the ground, which is ground number 3, physical pin. On our push button, GPIO pin 14, this represents a single leg. Actually on the board is a double leg, but we're only using single, so I'll put up with a single right now. That's all we really need. So we got coming to one side of the leg, and then it's normally open right now, and then the other side of the leg is going to the ground, run to the physical pin number 3. Alright, let's head over to the code. This is for lesson number 17 by Paul McWhorter. Bringing in our libraries. We're going to bring in a machine with the class pin, bring in the library time with the class of sleep milliseconds. Our global variables are our button pin number 14, which is GPIO pin 14, red LED GPIO pin 15, declaring a 100 millisecond and a 750 millisecond delays. Creating our object, my button pin, butt pin, that was representing a pin 14, and it's a pin in because we're reading pin inwards from that into the Pico W, and it's a internal pull-up resistor, which is a 100K. Then on a red LED, we're using the pin number 15, and it's a pin out because we're wanting to communicate out to from the Pico W. And then we're declaring a status of off. We'll do that in the loop here, and we'll show why. We're going to do a try and except. While true, we're going to read button status, which you're going to read the value of the button. Then we're going to go into an if statement. If the button status is 0, if that's true, then we're going to go into another if statement. We're going to have a if inside of an if to be able to get this to stay on and shut off when we push it. So then our if statement of inside, we're saying that the LED status is off, which we declare it's already off, and then when we push on the button, because normally it's 1 because we have a pull-up resistor, therefore we're reading off the ground, so it's always going to have 1 because we have a normally open button. When we push on the button, now it's going to be closed. And when it's closed, we're going to be given a reading status of 0 because we're going to have no more resistance. We're going to have the flow is going to go through it, and it's going to go to the ground, and we're going to have a 0 indication. So it says here, if we have a button status of 0 because we pushed it down, and our initial LED status is off because we called for it here originally. So this is our first push. We're going to turn on the LED, and then we're going to change the status to on. So the LED is now on. And then we're going to put a delay. That's in case if someone pushes on the button and takes some time before they remove their finger off the button, it won't sit there and flicker on and off, on and off, and on and off. Now we're going to go into an if statement, another one, else if the LED status is on and we push the button again. So we're checking to see if the light is on when we're pushing the button. If it is already on, now we're going to turn it off. And we're going to turn back the LED status to off. Therefore, it can run through it again. And then we're going to, once again, put a delay. And then I did, for the purposes of printing down here, the status of the LED and the status of the button. Then I put an overall delay across the whole thing, so it's not just running continuously super fast down here in a printout. Alright, with that said, let's turn on the camera for the board. You can see the board right here, and here's my little push button way over the other side, so I'm going to try to keep my finger out of the way. Yeah, whoop, I'm trying to find it here. Blindly finding it, I found it. Okay, so I got my finger up, and we're going to start our running. Right now it says our LED status is off, and the push button is showing 1 because we're not pressing it. Press it down, light it up. Alright, now we see here that LED status is on, and once again my finger's up, so the push button's up. We have not entered into the second part of our if statement, so we're running through this one. Nope, because we are not pushing it down, so we're just showing the LED status and printing out. Now if I push down again and let up, now we ran through, yep, it's on, but it was off status, so it didn't go through this block. But then it read here, oh yeah, this one's on, and we're pushing it down. Now we turned it off. And we turned the status to off now, so we can actually go back into this. Well, that was pretty simple, straightforward. If you have any questions or comments, leave them down below, and I'll do my best to return it. Until then, well, until next time, be safe out there, everyone.